Hello everyone. Last session actually we have discussed about the Darcy's law. So this session we will cover a few more points. As we know, what is meant by Darcy's law? Like Henry Darcy, he has developed one equation. So that equation I'll just mention on the board here that V is equal to K into I. Now uh, when we say K into I, K is the coefficient of permeability. So in this case, we can mention here that K is coefficient of permeability. Coefficient of permeability. In case of this I is nothing but the dH by ds. So this dH by ds is hydraulic head. So this dH is we can even write in a different way also, that H1 minus H2 hydraulic head or piezometric head at two different points divided by distance between these 2 points. Now this how can we find out the K, or what is meant by K, that we can discuss in detail. Even this particular law is basically uh, applicable as there is the constant. This particular law is applicable when Reynold number is 1 for the porous medium. So to find out the Reynold number for the porous medium, actually the formula that is not like a general formula which we use for the channel flow to find out the Reynold number, like laminar, turbulent and all. Here this laminar flow, in case of porous medium, the formula or the number is different. So that we will discuss now. This Darcy's law is basically applicable when Reynold number is equal to 1, or unity we can say. Now in this case, basically when we say the Reynold number is equal to 1, what should be the formula? So that formula I'll mention here for the Reynold number. So Reynold number, generally when we see the flow through open channel, the values, or the, like, if the flow is transient, there is a particular limit. So turbulent, there is a different. For laminar it is different, but in case of porous medium, actually it should be the laminar, and that to limit to the unity. So unity is equal to, unity means 1. So the formula for this Reynold number is equal to, Re is equal to V into, so this is V is the apparent velocity, into D into A, dA divided by V is equal to, or it should be equal to 1. Now here this V, this V is nothing but the apparent velocity. So velocity of the flow we can say. This dA is basically representative particle size. Usually it is taken as dA is generally taken as d10. So now this dA is taken as a d10. So what is meant by d10? So d10 is basically when actually where it represents as a size such that 10% of aquifer material is of smaller size. So uh, whatever the aquifer material is there, so 10% of which is in a smaller size. So this is d10. Also generally d10 is taken here. This V is apparent velocity, and there should be the difference between this V and this V. Actually here this one is the kinematic viscosity. So I will just write same V in a different way, so that we can recognize the difference between the kinematic viscosity and the regular velocity which I have mentioned over here. Now coming to the next point, like, so through which we can find out the Reynold number, and it should be unity. Now the thing is that whatever the velocity we are seeing, that this apparent velocity and all, actually this apparent velocity again depend on the whatever the particle size is there, shape is there, many things are there. So this apparent velocity, or we can say the actual velocity basically, that we can represent as VA. So VA can be different from V. So how can we get the VA? If we just divide this V by porosity, then we get the actual velocity through that particular porous medium. What would be the velocity? So generally this velocity can be obtained by tracking a tracer, so that can be added to the groundwater, and then we can find out the actual velocity. This actual velocity we can also mention, we can the similar word can be bulk pore velocity, so we can call it as a bulk pore velocity as well. So this is all about Reynold number and how can we find out that, and how can we find out the actual velocity through porous medium. Now the next part is the most important one, which is about the coefficient of permeability. So we will discuss in detail about the coefficient of permeability, which is generally represented by K. So I will just mention over here K. So that is coefficient of permeability. We will select a particular pencil. So yes, so now coefficient of permeability, the unit is like velocity only, and that can be represented as centimeter per second. So this K, the formula to find out the coefficient of permeability, K is equal to CD into actually this is the C into dm square. So I'll just mention the dm square. So the dm is nothing but the medium size of the particle, C into dm square into gamma by mu. So this gamma by mu. So what is mean by C, what is mean by dm, and all that we will discuss now. This dm is basically mean particle size of the porous medium. So this dm is the mean particle size of the porous medium. This C is the shape factor, actually the shape factor which depends on basically porosity, packing, shape of the grains and all. Now this gamma is basically unit weight of the fluid, and we know how to find out the unit weight of the fluid. Unit weight of the fluid formula can be rho into g, whereas rho is the density and g is the acceleration due to gravity. This mu is the dynamic viscosity. So in this way we can find out the K. So this K is the coefficient of permeability, which is inversely proportional to the kinematic viscosity. So we can also write this K, which is inversely proportional to the kinematic viscosity. As kinematic viscosity increases, K decreases, and vice versa. So in this way basically we can find out the coefficient of permeability. This C into dm square, that is a shape factor into a mean particle size square. So basically there is another terminology that we can use instead of this CDM square. So K naught is another terminology. So this K naught is equal to C into dm square. Now what is this K naught? So K naught is also permeability, but there is a difference between this coefficient of permeability and this intrinsic permeability, or we can say specific permeability, because permeability can be dependent on type of the porous medium and even the properties of the fluid. So this K naught basically represents the properties of the porous medium, not properties of the fluid. So in this way we can calculate the K naught. So if we simply put this K naught here, we can get the formula that I will mention. The formula here, K is equal to K naught into gamma by mu. Now this same formula we can even write in a different way. K is equal to this K naught, instead of gamma we can put the rho into g, and this mu, as there is a relation that kinematic viscosity is equal to dynamic viscosity by density. So we can also write in another way, that rho into v. So finally we get the relation that coefficient of permeability is equal to intrinsic permeability into G by V. So this is also another way through which we can find out the permeability. One more terminology we will discuss, that is about the transmissibility. So I will just mention about the transmissibility. So transmissibility is nothing but the ability to transmit the fluid. So in this here only in this box I will mention transmissibility, that is T is equal to K into B. So what is meant by K? K is the coefficient of permeability and B is the thickness of the aquifer. Suppose this is the aquifer, so this represents B is the thickness and K is the permeability or coefficient of the permeability through this porous medium. So through which we can find out the transmissibility as well. Actually there is a relation of what is the relation of Darcy's, means what would be the unit and how we can convert all this, like intrinsic permeability, that which we can represent by K naught, so which may have a unit as a centimeter square or meter square. So basically this 1 Darcy is equal to 9.87 into 10 raised to minus 13 meter square. This is 13 meter square. So this is the basically relation between Darcy's to the meter square. So this is about the different formulas. Now we will solve the one problem on the numerical, so which will clear our concepts in depth. Yes, in this problem actually there are the different things given, like if we just read this problem, we'll have the idea that what is the given. So there was a tracer used through which actually the test has been done, and this it was found through that tracer that 10-hour time was travel from one well to another well. There are the two wells which has a distance of say 150, sorry, 50 meter. So this 50 meter is the distance. So what is given is basically this is ds, then distance between two wells, then zero point 0.5 meter is the elevation difference, so we can mention that dh. So this is hydraulic or the elevation difference. Then the mean particle size of the particle is given. The mean particle size of the aquifer is given, which is 2 mm, that is dm, and the porosity of the medium, that is n, which is 0.3, and v, that is kinematic viscosity, is also given, which is 0.01 meter sorry, centimeter per second. Now we are supposed to find out the coefficient of permeability, that is K, intrinsic permeability, that is K naught, and the Reynold number. So these are the three things that we are supposed to find out. So there are the different formulas which we just have seen. So what we can do is, when we solve any kind of such a problem, we should write down the formulas, so we get the idea that what is given and what exactly we should do. So what we will do, we will write down the formula for all. So as it has been asked that what is the K, so I'll just write the formula for the K. So K is equal to dH by ds, K is equal to V into dH by ds. K is equal to V into I is equal to dH by ds. There is another formula which is, so this K is equal to K naught into gamma by mu. So gamma is the unit weight of the fluid divided by dynamic viscosity, or there is another formula K naught into G by V, that is specific gravity divided by kinematic viscosity. So we can use any formula. So this is kinematic viscosity. Now the thing is that actually we should make the difference between this gamma and this mu, this kinematic viscosity. There's another formula which is needed, like it has been asked that what is the Reynold number. So for this Reynold number, actually when we find out the Reynold number, the formula is given, so which we just have seen. What is the formula for the Reynold number is, Reynold number is equal to V into dA by, V is the apparent velocity, into dA by this kinematic viscosity. Again when this we represents V, the first one, this one is the apparent velocity. So this one is the apparent velocity, which we can enlarge so that we can differentiate. Now from this Instead of solving this entire problem, I will just give you the hint. Like in this, first we will find out the coefficient of permeability. So V is the velocity that we can find out distance upon time. Distance is 50 meter between two wells. Time is given, that is 10 hours. That we can convert to the centimeter per second as well. We have got the answer as a 5 meter per hour, that is V. Now put the value of V here. DH is the hydraulic or elevation difference, which is 0.5 meter. DS is the again distance between two wells, which is 50 meter, and we'll get the coefficient of permeability. Now by using this coefficient permeability, we can find out the intrinsic permeability. So all other values are given, and the last one is the Reynold number. So we can find out Reynold number here. The apparent velocity is we are supposed to put dA is nothing but the dm, that is mean particle size, which is 2 mm, and V is the kinematic viscosity. So put these values and you will get the Reynold number. You will get the intrinsic permeability and coefficient of permeability. I would like you to put the answers in the comment for all this, whatever I have given the hints in detail. So we'll stop here. Thank you.